All right, Chapter 3, Section 3.2, the International System of Units. Way back in the day, they used a cubit, which was just the length of a forearm. There is reference to it that it was a pharaoh's forearm from the pharaoh's elbow to his longest finger, but the pharaoh wasn't specified. This unit was first mentioned in written language in the 1300s, but I think you can see what the issue is. We would all have a different length for a cubit. So we now have a standardized system. We are using the metric system, even though my picture shows miles, and it's called the International System of Units. Our 5 most common units: liters, kilogram, Kelvin, second, mole, and meter. Your abbreviations for each of these: a liter is a capital L, a kilogram, kg, capital K for Kelvin, a lowercase s for seconds, an MOL for a mole, that's a chemical unit we'll study, and a meter is a lowercase m. So these definitions, it's more for your interest rather than for you to memorize. We now define a meter as the length of a path traveled by light, I believe it's krypton light, in a certain time interval. And you can see it's 299,792, and then it's kind of broken up 458. So let me write that a little bit differently. It's 1 over 299,792,458 of a second. Okay? So this is pretty much the speed of light, but we're defining it as a time unit. So that's the true definition of a unit. These are not my dogs. I have chocolate lab. The kilogram. Notice this kilogram. This is the prototype. Everything is compared to that kilogram. Look at picking it up. They have like special padded tongs. So this is in Paris. Notice the top of it. They actually evacuate this chamber, and there looks to be multiple chambers. And they may fill it with a noble gas atmosphere like argon, but I don't know that for sure. So the kilogram used to be defined as the mass of a cubic decimeter of water. But now they've made a prototype, and there's special places, I know, like in the United States, our standards of weights and measure, and they transport their prototype for the U.S. and compare it to the one that's kept in Paris to see how closely they match and make any adjustments. Okay, a second. I'm not going to read that number, but it's the duration of that many periods of the radiation corresponding to the transition between 2 hyperfine levels of the ground state of the cesium-133 atom. So cesium, that's an isotope, which we'll be learning about ever so soon. And that's the definition of a second. The Kelvin. It's a unit of thermodynamic temperature, and it's the fraction of 1 over 273.16 of the thermodynamic temperature of the triple point of water. Triple point of water is when water exists as a solid, a liquid, and a gas. The mole. It is not a critter in chemistry, but it's the amount of substance of a system which contains as many elementary entities, atoms, say, molecules, as there are atoms in 0.012 kilograms of carbon-12, and that's an isotope. You could also say 12 grams of carbon-12. The symbol of mole is MOL. Here's our base units one more time. Prefixes are handy, and we'll be using these for conversions, so just a little bit of review for you. If we have a meter, we could also have centimeters, and if you look up the word centi, means a hundredth, or 10 to the minus 2. If we have millimeters, milli means a thousandth, so we could have 10 to the minus 3 is the definition of milli. You probably know it as, gee, there's 1,000 millimeters in 1 meter. Or you might say, oh, there's 100 centimeters in 1 meter. We'll be looking at these more closely. For mass, our common units will be kilograms, grams. A kilogram is 1,000 grams, milligrams, 1,000th of a gram, and micrograms. So just some conversions. We know there are 1,000 grams in 1 kilogram. Put the 1 in there. There are 1,000 milligrams in 1 gram. And micro, sometimes you see the symbol like this. Micro is 10 to the minus 6. And there are 1 times 10 to the 6 micrograms in 1 gram. Temperature. We need to be able to convert from one temperature scale to another. Of course, most of our weather measurements are in Fahrenheit, but in chemistry we're going to use degrees Celsius, usually in the lab, and then we'll need to convert to Kelvin when we do certain calculations. So to convert to Kelvin, you take your Celsius temperature and add 273. To convert from Fahrenheit to Celsius, we're going to take your Fahrenheit temperature, subtract 32, divide that difference by 1.8, and you'll get your degrees Celsius. If you're going from Celsius to Fahrenheit, you want to multiply your degrees Celsius by 1.8 and add 32. I tend to memorize this one or remember this one, and then I just rearrange it to go back. So that would be my hint to you. I will give you a sheet with all of these equations on them in class. One more topic that we should look at is the energy units. Energy units, you probably know it as calories, just like when you're eating something. But I'm going to call it a heat calorie versus a food calorie. Its definition is the energy necessary to raise 1 gram of water. There should be 1 right here. 1 degree Celsius. Another unit that's used for energy is called a joule. It's abbreviated just with a capital J. And 1 heat calorie, or true calorie, is equal to 4.184 joules. Now, when you eat something, let's say you have something that has 200 calories in it, it really is, if you look at the labeling, that's a capital C. And a capital C is equal to kilocalories, which means that's 10 to the third. So if I multiply this out into scientific notation, we have 2 times 10 to the 5th true calories. Alright? So food calories are really kcals. If you start looking at packaging when you go to travel, I know in Europe they use joules, but sometimes you'll see the equivalency in kcals as well. Alright, that's it. See you later.